Hi, I'm Ryan of MidNite Solar. Today I want to talk about our Birdhouse, our disconnecting combiners, and our battery disconnect modules assembled as a rapid system shutdown, if you will. The combiner boxes in birdhouses would be used predominantly for purely grid tie. They're high voltage disconnecting combiners. In the birdhouse, there's no batteries involved. When you do add batteries to the system, be it a grid tie of battery backup or an off-grid system or an AC coupled system, then we have battery disconnect modules. We'll talk about them a little later. What I really want to do is bring you up to speed left to right here, and then I'll explain the functionality, and then we'll go through some of the warnings that we get from the birdhouse. The first thing I want to talk about is the combiner boxes, the power supply boards, the switches, etc. As you'll see, each one of these combiner boxes has a power supply board in it. This is an add-on that you put in the combiner box, or we can put it in if it's purchased that way. And what that does is it stores energy to turn off the switch. It also has a power supply in it that's powered off the PV array to charge that capacitor up to flip the switch, and also keep the rechargeable batteries in the birdhouse charged. So what you have is you have enough energy here to trip this no matter what during the day, and even at night, powered from the sun. Then you have rechargeable batteries in here that will give you 2 or 3 days of redundancy if there's no sun. And then inside the birdhouse, we actually have a power supply that takes 120 volts AC in and keeps those batteries trickle charged if they need it as a last, third redundant effort, if you will. I want to point out that on the birdhouse, if the batteries do go low, it's going to give you a visual warning the batteries are low, but when they get almost too low to do anything, it's going to turn the whole system off to make the system safe for you and let you know the batteries are worn out, or whatever the case is, the AC circuit got shut off, just whatever. It's going to let you know there's a problem, but it's going to make it fail safe, if you will. I also want to point out the Ethernet jacks. I'll explain how the Ethernet cabling goes later. And I want to point out this little jack over here with the relay. This is a set of dry, normally open, normally closed contacts that allows the birdhouse and the rapid system shutdown to interface with things like burglar systems, fire alarms, etc. So if this was on, say, a Home Depot building or a Walmart or a Lowe's, and the button gets pushed, we can actually send a signal back to the security system to notify the manager or whoever that this has been shut down for whatever reason. Either a firefighter is on site or somebody's pushed it by accident, but it can notify somebody so that the right things happen after that. Combiner box, birdhouse, battery disconnect module. Like I say, I want to point out the Cat 5 cables. As you notice, they're just kind of hanging here willy-nilly in free air, and that's on purpose. So I wanted to show you that it's just standard off-the-shelf Cat 5 cable, standard pinouts. We do manufacture a 600 volt UL listed Cat 5 cable that can be run in the same conduit as your AC and DC wiring. But I wanted to show, for the purpose of this, that it's standard Cat 5 cable, standard pinout, so it's easy to use. And it simply daisy chains. So what that means basically is you can have, say 100 devices. You could have 40 combiner boxes, 50 or 60 battery disconnect modules, and 6 or 7 birdhouses. And they daisy chain one to the other, to the other, to the other, to the other end. I do want to point out that due to the way the birdhouse works and its fail-safe circuitry, that the birdhouse cannot be on both ends of that string. They have to be all together in a line. They can be on either end, or they can be in the middle somewhere, but you can't have birdhouses on both ends, otherwise you'll get a fail-safe signal from both ends, which will cause the system to not turn off if a cable is damaged. Sums up the wiring, I believe. Like I say, Cat 5 cable, daisy chained one to the other to the other. I want to talk a little bit about the birdhouse now. So what you're seeing here, visual indication of what's actually happening on site. The solar array is on, meaning that the combiner switch is actually in the on position. The switch is on. Power will be flowing if the sun is out. Solar is off. AC in, battery low. I'll turn the combiner box off. You'll notice lights will change to solar is off. AC in, we're putting 120 volts to both of these birdhouses to keep the batteries charged. And battery low, if the AC power goes away and the solar power cannot keep up, say it's been cloudy for 3 or 4 days, you might notice this light come on, meaning the batteries are low, indicating there may be a problem with your dedicated branch circuit that's feeding these. That is something I didn't mention in the beginning, but when you do wire up the 120 volts to these, I do highly recommend a dedicated branch circuit just for these, so that they don't get turned off if something else is being serviced or whatever the case may be. I'm going to turn the combiner box back on, and the birdhouse is going to tell us the combiner box is now back on.
The combiner circuit breaker is closed.
I also wanted to point out that you notice each light bulb works independently. So as you can see, they're all independent at the moment. Battery disconnect module, again, independent lights. So now I want to show what happens during the daytime. Sun is out, firefighters roll up, they hit the button.
The combiner circuit breaker is open. There are still lethal voltages present between the solar panels and the combiner, which is a gray box with a red handle. Note that the handle will still be in the on position. However, the voltage is turned off internally.
Okay, so that was the daytime announcement. Now what I'm going to do is I'm going to reset the whole system.
The combiner circuit breaker is closed.
And I'm going to open this fuse holder here, mimicking this fuse holder. I'll get the right one, bear with me. That's mimicking PV input. So now we've turned off the PV to the combiner box, but as you can see the switch is still on. So now what we're going to do is we're going to give you the nighttime announcement. Firefighters roll up, hit the button.
The solar system has been disabled. There are no voltages coming from the solar panels. The system voltage is 0. To cancel this announcement, press and hold the red button for 5 seconds. Goodbye.
Okay, I'm going to turn it back on again, one more time.
The combiner circuit breaker is closed.
Now I'm going to talk a little bit about the battery disconnect modules. This box over here is an example of a system. Basically, this would only be used again when there's batteries in a system, be it battery backed up grid tie, AC coupled with batteries, or off grid. Each one of these modules controls a shunt trip breaker. We have shunt trip breakers in every flavor. We have DIN rail, we have panel mount, we have them all the way up to 250 amps. So we can turn off virtually anything that's battery powered. Inverters, loads, charge controllers, whatever the case may be. And again, the reason for that is, the rapid system shutdown requirement in the code is going to require that the whole system be brought down to a safe voltage within so many seconds with a single push of the button. So this accomplishes that by tripping off each switch independently. Basically, again, standard Cat 5 cable, wires up to the shunt trip switch, and just wires right into your battery bank, 24, 48 volt batteries, wires right into the battery bank for power, and turns the breakers off when you push the Birdhouse button. Also, again, the redundant cable issue. If the cable is cut, the combiner box is going to know that. If the cable is damaged, it's going to shut off everything upstream of that cable. As you can see there, shut off the combiner boxes because we damaged the cable going to those combiner boxes. If the cable is unplugged, it's just going to shut the system down. If the cable is actually damaged by a fire or a mouse, we'll say, it'll shut the whole system down. So as you can see, I unplugged the cable, so it only shut down what's upstream of the cable. If I'd actually cut the cable, it would shut the whole system down, and then it would give us a warning the cable is damaged.
The combiner cable appears to be damaged or unplugged. You should call your service technician and assume that lethal voltages are present throughout the system during daylight hours.
That's the warning it would give us when the cable is unplugged or damaged. Again, if I'd have cut the cable, it would shut the whole system down because it would assume either vandalism
The combiner has been detected.
or fire or outside source, maybe a mouse is chewed through the wire. We don't know the case. If the cable's unplugged, we only shut down what's upstream. If the cable is actually damaged, we shut the whole system down. It's a pretty quick rundown of the rapid system shutdown. Please look at our other videos of actual installations of these for more real-world examples of what we've done here. Until next time, I'm Ryan of MidNite Solar.